Okay, hi guys, welcome back to QBT. This week we're continuing our series on the particle model with a video on specific latent heat. Okay, and what is specific latent heat or latent heat? Well, latent heat refers to effectively the amount of energy that I have to put in or take away from a given system to make it change its state, so go from a solid to a liquid or from a liquid to a gas or vice versa, without actually causing it to have a change in temperature or pressure. And that might sound a little bit bizarre because we know that temperature is related to kinetic energy, and the more temperature that we supply to a system, the more those particles move around, and we have to give it energy in the form of temperature to make it change state. So it's a little bit confusing, but what's interesting, as I'll talk about in this tutorial with some graphs to help you understand, is that during the state change itself there's actually no change in temperature. And that's because the energy that is being used for that state change is going towards making and or breaking bonds instead of raising the temperature of the thing that you're concerned with. So it's really quite clever. But why don't you check out this tutorial and it will help you understand it in a bit more detail.
Okay, so let's discuss latent heat and specific latent heat in more detail, and let's also consider how we can use specific latent heat to calculate the energy needed for a state change to actually occur. Okay, so first question, what is latent heat? Okay, and the definition of latent heat is the amount of energy that is needed to change the state of a substance, and that would be written as E. Okay. And that is measured in joules, okay, because it's energy, which is great. But what is specific latent heat? Okay, well, it's similar, but specific latent heat, okay, which is sometimes written as SLH, okay, is defined as the amount of energy that is needed to change 1 kilogram of a substance from one state to another without changing its temperature. Okay, so that's the key point with specific latent heat. Okay, it's without a temperature change. Okay, and specific latent heat is written as L. Okay, like so, and we say that the latent heat is equal to mL. Okay, where m is mass in kilograms and L is your specific heat. Sorry, your specific latent heat in joules per kilogram. Okay, now using this lovely equation, we can actually tackle this question here, can't we? Because it says to us, calculate the energy needed for a state change to occur if the specific latent heat is 50 joules per kilo and the mass is 1.2 kilograms. So the way that we would do this is we would simply identify our variables, okay, and we would put those into our equation. We would substitute in our values. So we would do E is equal to 1.2 multiplied by 50. And if we do that, we come to an answer, of course, of 60 joules. Okay? And that is how we can use our understanding of specific latent heat and latent heat to answer a question such as this.
Okay, so hopefully that helped you understand specific latent heat in a bit more detail. So next time we're going to be talking about specific heat capacity and what that is and how that's different to specific latent heat. But if you understand this, then I'm sure you'll understand specific heat capacity too. As always, please like and subscribe. It really helps us grow the channel. Share it with your friends. It helps us get more amazing content to you guys, which we just love to do. But in the meantime, stay quantum. And if you're doing your exams right now, I hope it's going really well for you. Best of luck. Bye guys.